Welcome to the course Numerical Analysis. We are solving system of linear equations using different methods. In our last lecture, we studied the Gaussian elimination method and we solved two examples using this method. Today, we will solve system of linear equations using Crout's method. It is yet another method of solving a given system of linear equations. The method it can be implemented using 4 simple steps, and steps are really very simple and they require a little knowledge of linear algebra. Right, given a system of linear equations, we conventionally write it a times x is equal to b. This is what we have been doing using in our previous techniques, for example Gaussian elimination method, and this is the way we would write the system of linear equations in the form of matrices in school and college. Right. Step number 2 is we decompose the matrix A, the matrix of coefficients, into a lower and an upper matrix L times U and compute the elements of L and U. It's very simple. Soon we are going to see the elements of lower and upper matrices, L and U matrices, and we can very easily compute the values of the elements of these matrices L and U. The third step is that we put, instead of A, we plug L times U. In this equation, A times x is equal to b, we replace A with L times U because we have declared A to be equal to the product of L and U matrices. So we have replaced A with L times U, and we can write it like this. And if we assume that this is y, U times x is y, y is U times x, or U times x is y, we can write it L times, and we can replace this U times x is y, so L times y is equal to b. So we get two equations. One of them is Ly is equal to b, the other is y is equal to U times x. These equations are very important. These two equations are very important. The first of them is obtained by putting y instead of U times x, and the second is itself y is U times x. So it's very simple, right? And we compute y is y1, y2, y3. There can be many equations. There can be more than 3, 4, 5, 6. Using Ly is equal to b, the first equation. In this, while we find y using Ly is equal to b, we know b and we know L because we have already computed. In step number 2, we would have computed L. So we know L and we know b, and we can straight away compute y. And in step number 4, we'll find x using this equation number 2. X is also a vector, and it is the vector of our desired coefficient with desired variables x1, x2, x3, so on. Ux equal to y, this equation, second equation, Ux is equal to y, and we know U, and in step number 3 we have computed y, so now we can compute x. So next we are going to solve an example to better understand these 4 steps. Right, this is a system of linear equation containing 3 equations, and we are supposed to find the values of x1, x2, and x3 using Crout's method. Right. So now let's form step number 1. A is written equal to A times x is written equal to b. So A is the matrix of coefficients 5, 4, 1, 10, 9, 4, 10, 13, 15 times x, x1, x2, x3 is equal to b. 3.4, 8.8 and 19.2. So this is the first step. A very simple step. We have been doing it in school and college. Right. A is written equal to L times U. We assume L to be a lower matrix where we have a matrix like this: A, B, C, D, E, F. Coefficients non-zero elements in the lower diagonal, in the lower triangle, on the diagonal and in the lower triangle. So this whole is the lower triangle. So in the lower triangle we have non-zero elements, and upper and all other elements are zero. U is the upper matrix where we have A, B, C, D, E, F, G, H, and I. And on the diagonals we have ones, and in the lower triangle we have zero. So this is the general form of L, and this is the general form of U. If you put it equal to A, as we do in step number 2, right? So I have to erase it. If you put it equal to A, this is A, this is X, this is B. So step number 2 is A is written equal to L times U. A is 5, 4, 1, 10, 9, 4, 10, 13, and 15. It is equal to L times U. L is A, 0, 0, B, C, 0, D, E, F, times U is 1, G, H, 0, 1, I, 0, 0, 1. So if you multiply these two matrices, you have to just remember this: we have to perform Ly is equal to B, the step number 3 of this procedure, and just Ux equal to Y. You can do it. You can write these steps down because I'm going to erase it. Right. So if we multiply the two matrices on the right hand side of the equation, it becomes 10. Let me write this first matrix first. Is equal to, right, so A times 1 is A, plus 0 times 0 plus 0 times 0 is 0. A times G plus 0 times 1 plus 0 times 0 is 0. A times H plus 0 times I, 0, plus 0 times 1 is a 0, right? B times 1, we are multiplying these two matrices. B times 1, C times 0, 0 times 0. B times G plus C times 1 plus 0 times 0. B times H plus C times I plus 0 times 1 is a 0. D times 1 is a D plus E times 0 plus F times 0. D times G plus E times 1 plus F times 0. D times H plus E times I plus F times 1 is an F. So this is the matrix. This means that A is, now we can equate the elements one by one at the corresponding positions. If this matrix is equal to this matrix, this means the element at position A11, the first position, is equal to the elements of this matrix at the corresponding position. So this means A is equal to 5, right? And AG is equal to 4. This means that G is 4 over A, 4 over 5. And AH is 1, This means h is 1 over a is 5, 1 over 5, right? And now 10 is equal to b, or b is equal to 10. A is 5, G is 4 by 5, H is 1 over 5, B is 10, BG plus C is 9. BG plus C is 9. This means 10 times G is 4 by 5, 4 over 5, plus C is 9. So 8, C is 9 minus 8, C is up 1. And then BH plus CI is 4. Right, B is 10 times H is 1 over 5 plus C. C is a 1 times I is a 4. 5 2s are 10. So I is 4 minus 2. It's a 2. And we can go on and find all the elements of L and U matrices. And that will make our life easier, right? BH plus CI. All right, the last row, D is 10 and DG plus E is 13. D is 10, G is 4 over 5, plus E is 13. So 5 2s are 10, 4 2s are 8, E is 13 minus 8 is 5. And the last one is DH plus EI plus F is equal to 15. Right, D is 10, H is 1 over 5, plus E is 5 times I is 1 or 2, plus F is 15. So 5 2s are 10, 2 plus 10 plus F is 15. So F is 15 minus 12, 3. So now we have these elements computed for L and U matrices, and the rest of the steps, step number 3 and step number 4, are very easy. So now I'm going to write L and U matrices here. The L matrix is, we know it's an upper matrix where we have, it's a lower matrix where we have A, B, C, D, E, F, and 0. This matrix is A, 5, 0, 0, B, C, 10, C is a 1, 0, and D, E, F. D is 10, E is 5, F is 3. So 5, 0, 0, 10, 1, 0, and 10, 5, 3 is L. And U matrix is at the upper matrix where we have G, H, I, 1, 1, 1, 0, 0, and 0. This is 1, G, 4 over 5, H, 1 over 5, 0, 1, I is 2, 0, 0, 1. Now we have this matrix as U matrix, and that will make step number 3 and 4 very easy. We started with that AX is written as, it's just a reminder that AX is B, so actually we replaced A with L times U is B, and then we replace this as Y is equal to B. So now we are ready to find Y given this L and B. We know B, we know L. B is 3.4, we know B, this is 3.4. 8.8 and 19.2. Right. This was straightway written from the system of linear equations given. Right, L is 5, 0, 0, 10, 1, 0, 10, 5, 3. Right, and Y is Y1, Y2, Y3. This 3 by 3 matrix multiplied with the 3 cross 1 matrix will yield a 3 cross 1 matrix B. 3.4, 8.8, 19.2. Right. So now we can straight away find Y. This is 5 times Y1 plus 0 times Y2 0 is equal to 3.4. So Y1 can be written as 3.4 over 5 and Y1 is 0.68. The second equation would be 10 times Y1 plus 1 times Y2 plus 0 times Y3 is equal to this 8.8. Y1 is 6.8. 10 times 0.68 would be 6.8 is equal to 8.8. This means Y2 is 8.8 minus 6.8 is 2. And the third and the last equation to find Y3, 10 times Y1 plus 5 times Y2 plus 3 times Y3 is equal to 19.2. So 10 times Y1 is 0.68 times 10 is 6.8 plus 5 times Y2 is 5 times 2 is 10 plus 3y3 is 19.2. So 3y3 is 19.2 minus 16.8. This gives us y3 is equal to 0.8. So now we have y with us 2, that is y1 0.68, y2 2, y3 0.8. Now we are in a position to find x, the unknown set of unknowns x1, x2 and x3 using this, that this is equal to y. So ux is equal to y. Using this expression, using this fact, ux is equal to y, we can find x. U is the upper matrix, this one, 1, 4 over 5, 1 over 5, 0, 1, 2, 0, 0, 1 times x, x1, x2, x3 is equal to y. That is y1, y2 and y3 is 0.68, 2 and 0.8. So writing the first equation, x1 plus 4 over 5 x2, 1x1 plus 4 over 5 x2 plus 1 over 5 x3 is 0.68. The second equation would be 0x1 plus 1x2 plus 2x3 is equal to 2. 0x1 plus 0x2 plus 1x3 is equal to 0.8. So it's straight away, it's x3 is 0.8. Now we can put x3 here, 0.8. So x2 is 1.6 is equal to 2. X plus 1.6 is equal to 2. So x2 is 2 minus 1.6. It comes out to be 0.4. And if we plug x3 0.8 here and x2 0.4 here, we can find x1. x1 comes out to be 0.2. So x1 comes out to be 0.2, x2 is 0.4, x3 is 0.8. So now we have computed x, the final unknown factor of coefficients 0.4, 0.6 and 0.8. And the last step is verification. You can put these values in the original system of equation given and find that all three equations are satisfied by putting these values for x1, x2 and x3 respectively. And I am leaving this verification task as your homework. Right, that's all for this lecture. Thank you.